Okay, so exponential growth and decay. Have you ever learned anything about exponential growth or decay before? Yeah, how many times?
One.
At least twice. You start learning about exponential growth in Algebra 1 even, and then I know you've heard about it in other math classes and science classes, and you've seen this formula. It is. It's very similar to the A equals PE to the RT. In fact, they're pretty much the same formula. Okay, just one is what we usually use the A equals PERT for banking. The Y, or sometimes we call it the A, is the final amount or the current amount after a certain amount of time. What does C or P stand for? So if Y is the final amount, C is the initial amount. K, I looks a lot like a 1. So we typically don't have I's in formulas. And I also stands for imaginary number. So K is the constant in proportionality, and T is, of course, time. So let's think about this. If K is positive, we have exponential growth. Now, can you give me an example of a real-life situation of something that grows exponentially?
My bank account.
Bank account. What else? Populations. Bacteria. And then exponential decay would be when K is negative. Can you give me an example of an exponential decay or something that decays exponentially? Maybe some people's bank account. Yeah, radioactive stuff, half-lives, that's probably the most common example of that.
Drugs in people's systems.
Yeah, drugs in people's systems, it decays. Any like substances that are processed, prescription drugs, of course, but also other kinds of drugs. It decays exponentially. So it stays in your system a really long time. It's a lot less over time. All right, so let's look at this first problem. And I say up here that this is a two-step process. The biggest thing students mess up on is they read all this and then they're like, okay, I want to do one thing to find the answer. You can't. Okay, the first thing we need to do is find K. All right, and K is going to be specific to that problem. So it says, suppose that 10 grams of plutonium were released into the Chernobyl nuclear accident. How long will it take for 10 grams to decay into 1 gram? The half-life of plutonium is 24,360. Okay, this whole how long, blah, 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 that we are going to do in the second part. We're going to answer the question. Okay, I'm not even worried about the 1 gram yet. Okay, to find K, what we need to do, let me rewrite the formula right here. And this is a formula you need to know. This won't be given to you. So we got to think, okay, well, in a half-life type problem, if you start with 10 grams, after 1 half-life, how much do you have?
5 grams.
5 grams. Okay, and so you start with 10, e to the power of k, and then you say, well, how long is a half-life? It's 24,360 for plutonium. All right? Algebraically, we can solve this, or we can solve it using graphing and find an intersection, or we could even use the solve feature in the home screen of your 89 calculator. Okay, I want to go ahead and solve it algebraically, just so that you understand how it's done. Okay, so first thing is we got to divide by 10. All right, do you remember how we get rid of that e?
Take the log. So
Take natural log of both sides. Good. So the 24,360k is going to equal natural log, and I'm going to go ahead and write this as 1/2 instead of 5/10. Of course, you could write 5/10. And so then just k would be natural log of 1/2 divided by 24,360. Okay, and in fact, if you are a good memorizer, you could just memorize this. To do a half-life, your k is always going to be natural log of 1/2 divided by the half-life. In fact, this works for other types of problems. Let's say we had a bacteria that was tripling every, we'll say, 20 hours. Okay, then we would do natural log of 3 over 20. It's always natural log of the scale that it's multiplying or dividing, and then over your time. Okay, so this is where we're going to use our calculator. Okay, first off, when I type this in, am I going to get a, oops, sorry, I hit second twice. Am I going to get a positive or negative number? I did it again. Here we go. What do you guys think? Is this a growth or decay problem?
Decay.
It's a decay. So should my K be positive or negative? Negative. So that's an easy way to check that we did this right. Now I know I want a decimal, and so I'm going to go ahead and do diamond enter. Okay, now I get this number. Some of you on your calculator, it may say like negative 0.000028. It may not give it to you in scientific notation. Either way, what I would like to do here is to store this in the calculator, because if I'm going to use this number, I don't want to round in the middle and then round again at the end. Especially in exponential problems, the error is going to be really bad if you do that. And so I'm going to show you how to store alpha K. Why not? You could use any letter, but I'm going to use K because that's what we call this anyway. So alpha K. So from now on, if I clear this out and I just hit alpha K and I press enter, it's stored temporarily for that number. All right. So what we want to do now is do the second part. How long? What are they asking you to find when they ask you how long? Time. So we want to say, what is the time for 10 grams to decay into 1 gram? So this 1 gram is the new Y value. It's saying when you only have 1 gram left and you start out with 10 grams, what is the time? Okay, and remember, I'm going to write K here. I'm not going to write the decimal, but we know that K is that decimal, that natural log of half over 24,000. All right, again, you could solve this a variety of ways. I'm going to solve it algebraically, first by dividing 10, and then taking natural log. And then to get T by itself, you would divide by K. Okay, so that's how you do it algebraically. If you want to use the solve feature, of course you could. So in the calculator, I'm going to do natural log again of 1/10, or you could do 0.1 if you wanted, divided by alpha K. And I get 80,000. 80,922,168 years. Is this reasonable?
Yeah. I think it's about right.
Yeah. But we got to ask ourselves this, because it's easy to make a mistake. So let me ask you, if it took about 25,000 years for the thing to go from 10 grams to 5 grams, what's going to happen at 50,000? To 2.5, and then another 25, which would put us at 75,000, would put us at like about 1.25. And so a little bit more than 75,000 would put us down to 1. That's how you can kind of check your work. All right, this next problem, you're actually probably going to be more comfortable with. So suppose you make an initial investment of $10,000 into an account where the interest is compounded continuously. That just means, hey, use this formula. In 5 years, the amount of money in your account has doubled. What is your annual rate of return, and how much money will you have in 10 years? So again, I'm going to do this in 2 pieces. All right, so if my money doubled, how much do I have? 20,000, right? 10,000 is how much we started with. R is my rate, and T is 5 years. I get that there's a 10-year at the bottom. That's when we get over here, we're going to say, hey, when T equals 10, what's your amount? Okay, let's go. We're going to do that separate. All right, so again, you can solve this by using the solve feature, graphing. I'm going to solve it algebraically, just so that you know how that's done. divide out that 10,000, which would give you how much over on the left-hand side?
2,000. Oh wait, no, 2.
2, right? So then what would just 5r equal? Natural log of 2. And then you would divide by 5. So remember the shortcut I was telling you? If you're good at memorizing, if you like shortcuts, think of it this way. R, or K, is the natural log of the scale. Doubled, the scale would be 2, divided by however long that took. Now this is specifically asking us for our rate of return, so I am going to have to write down that decimal. So I'm going to go second natural log of 2 divided by 5. And if you know you want a decimal, go ahead and hit diamond enter. All right, so then I get 0.138629. Okay, is that my R? I mean, it is R, but is that my annual rate of return? Or is there something I need to do since we're talking about a rate? What?
No, never mind. I'm not talking anymore.
It's okay, you're trying. If you go to the bank and they say, this is your rate, they're not going to say your rate is 0.138629. They're going to say it's 13%, 0.86, and we could go ahead and say 3. Make sure your final answer is accurate to 3 decimal places. Okay, so change that to a percentage. That's all I did. Okay, now let's do the second part. How much money are we going to have? So what's A? Remember, we started off with $10,000. My R, I already have that. Oops, I don't have it stored in my calculator, but I will in a minute. And how much will we have after 10 years? Who in here doesn't have their calculator? You ready? Austin? You're going to figure this out in your head. You can actually do it. I'm not being mean. Think about it. I'm not being mean. All right, everybody else who has their calculator, let's go ahead and store that in. And you can use alpha K again. You could use alpha R. It doesn't really matter. And so then we're going to type in 10,000 E, so second X is E, and then to the power of alpha R times 10, or we can type in 10R. And we get an even 40,000. That's interesting. Is that what you got, Austin? You just go, yep. Okay, why did it turn out to be so even? My money doubled. We're just going to ignore that. It's okay. Our money doubled. Yeah, it just doubled twice. Doubled in 5 years, doubled again in the next 5 years. Okay, typically the problems don't turn out like that. Okay, so that's that. All right, for the rest of class, like I said, we're going to do that little activity, but what I also want to do is kind of practice some more problems of what we've already done. So on this one, we're going to solve this differential equation. Okay, the first thing we need to do is replace that y prime with a dy over dx. Are we used to seeing dy dx in the middle of the problem or by itself? By itself, so let's do that. If the problem looks weird, make it look more like what you're used to. All right, it still kind of looks weird because the x's and y's are kind of jumbled together. What can we do on the right-hand side that would separate them? Yeah, factor. Factor out a5x. So then you'd be left with 10 minus y. And this is the point when you say, okay, I'm going to divide that over to the other side. And this is what we have already done. This is a pretty tough one. The one on the quiz is not going to be this tough. This is like pretty tough. All right, we're ready to integrate. Anybody think they know the integral of the left-hand side? Just off the top of your head. You are so close. It's awesome, but you're missing one tiny little thing. No, you're the only one that said it, so that was good. Well, there is a plus c, but let me ask you, if we were doing this as u substitution, what would we let u equal? 10 minus y, and so du would be
Oh, negative.
negative. So see that right there? That's going to go in front. You were tricked. But you had the right answer. You were just very, very close. So just be careful about that. All right, so this is 5 times a half x squared, and this is where we're going to put our plus c. All right, now the whole idea here from here is to get y by itself. Okay, so the first thing that I would like to do is to get rid of that negative. So how do you get rid of the negative? You just divide or multiply by negative, either or. Okay, so that's going to give me negative 5 halves x squared. And this is going to bother some of you. I'm still just going to write plus c. Because remember, c is just some number. If you divide by a negative, isn't it still just some number? It's a different number. We could be using subscripts, but we don't have to. And that confuses more people than it helps, I believe. Okay, now how do I unlock the natural log? This is kind of reverse of what we did at the beginning. Log base e. So 10 minus y is actually going to be e to that whole right side. And this is really going to show those of you who practice this. What do you do with this plus c now? Yeah. And some of you really thoroughly understand why we can do that. Some of you don't. I can explain it to you better later on if you don't, but it's important that you do that, even if you're not quite sure why. I don't normally say that, but it's just something that just doesn't stick with a lot of people. Okay, next is I'm going to subtract 10. So this is going to be negative y equals ce to the negative 5 halves. I did this. Oh, yeah, sorry. I just got sidetracked for a second in my mind. All right, minus 10. So what would just y equal? We're so close to being done. Do I have to write negative c, e?
No, because C is just a number.
C is just a number. You do have to change that minus 10 to a plus 10. Because 10 is not just some number. It is 10.
If we wrote that,
If you wrote a negative here, it's not wrong. And in the end, if we had if you had an initial condition, your C and my C would be different, but our final answer would be the same. Okay? So it's totally fine. That's the thing about it. It works both ways. Okay, turn the page. All right, this next part is kind of cool. This is not something you're going to need to do very often, but you're going to notice something at the end. So wait for it, and you're going to tell me what you notice at the end. All right, in many applications, the rate of change of a variable y is proportional to the value of y, meaning the derivative equals some number times the y value. This is going to happen with exponential functions. And so that's why it's written that way. We're going to solve this equation. Okay, first thing, we got to move this y to the other side. Okay, the k is a number, so I could move it, but I'm just going to leave it. And of course, the dt gets moved over. It's t in this case and not y. Okay, integrate. The integral of the left side is natural log of y. What is the integral of the right side? Okay, that's a really common answer, but it's not right because here's the deal. If that was t, dt, we would do 1/2 t squared.
Oh, that makes sense.
But k is a number. So what if we were taking the antiderivative of 2? 2x, or in this case, we would write 2t. What's the antiderivative of 6?
6x.
Or in this case, 6t. So we're going to write kt. All right, so then what would just y equal? Oh, and I forgot my plus c. E to the kt plus c, and what happens to this plus c? And and look at this equation.
Oh my gosh.
Your mind blown? This is an equation you've never really understood where it came from. Now you do. All right, we are not going to do that part because we've already done it. We have already discussed this as well. I kind of messed up on the notes. All right, let's turn the page here. Now, all day, this has been causing some people some problems. Not because it's that difficult, but because students look at the sign and they're like, I don't know how to do it, it's trig. Okay, so I'm going to just, you're going to be fine, okay? One of these belongs to A, one belongs to B. Okay, by answering these two questions, you can figure out which one's which. Zero slope is your friend. All right, so when I want to know if the derivative of sine is 0, sine of what is 0? This is the only trig you have to know. Sine of what is 0? Yes, but there's an easier one to pick. 0. Okay. In other words, x plus y has to equal 0. So for now on, we're just going to ignore the sign. We're just going to focus on the fact that x plus y has to equal 0. Well, what does that mean about x's and y's? What type of numbers, when you subtract them, or sorry, add them in this case, make 0? They're going to be the same. Or we could solve it. They're going to be the same, except one's going to be positive and one's going to be negative. Or say it would be like negative 3, 3. Does that make sense? Like 2 plus negative 2 is 0. Negative 3 plus 3 is 0. Okay, something similar is going to happen right here. In order for this slope to be 0, x minus y has to be 0. So what's the relationship between x and y? They have to be the same. So this would be like 1, 1, 2, 2, and so on. So what I want you to do is to look at these two slope fields and tell me which one of these matches sine of x minus y. In other words, which one has these kinds of points with a horizontal 0 slope? Is it A or is it B? What do you guys think? I got 1A. Don't get, this slope field is so weird. All you're looking for is 0 slope. So like, see how you see 0 slope here?
Yeah.
You see it now?
Okay.
Okay, which one of these fits this right here? A or B? B.
B is 2 and A is 1.
Yeah. Okay. And so this one fits A. Because see how it's like 1, negative 1, 2, negative 2, 3, negative 3. And this is not an easy, I'm not saying this is easy, but what I am saying is it's doable, but you have to focus on something, some kind of pattern. You cannot just sit there and write out the T-chart to do this one. That would be ridiculous. Okay, let's do one more. We're not going to answer those other questions, by the way, if you notice that. Okay, now I have two different ones. Again, with the sign, just ignore the sign if you need to. Okay, do you notice how one of these has rows and one has columns? That didn't happen on every slope field, but it is happening here. See how A has rows? Meaning, every time y is of a certain value, no matter what x is, you have the same slope. Over here for B, we have some columns. So I'll pick this one. Okay? When x is, we'll just say 4 or something, I don't know. When x is this, it doesn't matter what the y value is. You see how it's the same all the way up and down? So I want you to think about which one belongs to sine x cubed, which one belongs to sine y cubed. I want you to write it down on your paper. Just take a guess if you're not sure. look at it, just try it, just give it a stab, and I want you to compare with the people at your table. See if you got the same thing. Maybe they know what they're doing and they give you a hint. You're like, oh, we're here. It's okay if you're wrong. That's what your pencil eraser is for. If you're using pen, you just scratch it out. It's okay. Okay. Which one does sine of y cubed belong to? A or B?
A.
Why?
Because vertical.
Yeah. Do you see how all along here y has the same value although the x is changing? It's like x, who cares about x? We're looking at the y values. That's why this one belongs here. I mean, it belongs there for more reasons than that, but that's how you can kind of narrow it down. Okay? You're going to use some of these strategies in the activity now. The number.